Hello and welcome to the next topic in Unit 13, which is right triangles in real life. What we're going to talk about today is how this stuff that we're learning about right triangles and Pythagoras and all that stuff is important and useful. Like, for instance, let's say you were at Talbert Middle School and you spent all day learning, and at the end of sixth period the bell rings and you decided to walk home. So, let's say you walked east on Brabham Drive, and let's say you went about 700 feet before you got to Hickory Lane, and then you walked north for about 800 feet. And by the time you got to the edge of that green belt, your friend texts you, and your friend says to you, "Hey, did you know that you forgot your math book? It's lying right here on the grass in front of the school." And so you have to walk all the way back, but this time you go across the green belt, across the grass, across the blacktop, through the library in a straight line. How far did you have to walk back? Did you have to walk 700 plus 800? No, you went a shorter route. But how much shorter? What is that distance? Well, basically, is this not simply a right triangle problem? Yes, because Brabham and Hickory are perpendicular to each other like many streets are. This scenario forms a right triangle, and in any right triangle you can always use the Pythagorean theorem, which says that leg squared plus leg squared equals hypotenuse squared. 700 and 800 are the legs, x is the hypotenuse because it's the crooked one, it's the longest one, it's the one that's not touching that right angle, and now all we have to do is solve this problem. So 700 times 700 is 490,000, 800 times 800 is 640,000, and then you add those together, you get 1,130,000, and then to get x you've got to unsquare that so that we know what x is, and when you unsquare that, the answer to our problem is about 1,063 feet. Now you had to say about that because that square root didn't come out perfectly nice and even, and we had to round up a little bit. But basically, this was just a Pythagorean theorem problem in disguise as a word problem. And what I want you to understand today is that we can do this with all kinds of word problems because right triangles are everywhere. That's right, right triangles are everywhere. In fact, they're in all kinds of sports. Right triangles are in origami and woodworking. They even are in ancient artifacts and history, and they are even in current artifacts of current history of nations that exist today, and all kinds of symbols of national pride have right triangles built into them. And even the way that you fold some of these symbols of national pride and store them have to do with right triangles. In fact, right triangles also happen when the sun casts a shadow. Right triangles also happen when a plane up in the sky has to communicate with an air traffic control tower. And when satellites up in the sky communicate with the Earth, they make right triangles. In fact, the Earth and the Sun and the stars, way, way, way outside of our solar system, can make right triangles, and that's how we calculate astronomical distances. And it's also how we can calculate not so astronomical distances, like how far a boat is off of the shore. That's another right triangle scenario. Where else are right triangles? Well, right triangles are in roller coasters. Well, we're not going to talk about ladders. Right triangles are even in ugly sweater designs. They're in Pythagorean-shaped birdhouses. Right triangles are even in the way some of you cut your sandwiches. And, of course, right triangles are found in the design of the famous hypotenuse. Oh, that was a bad one. Where else are they? Interior design uses right triangles all the time. And exterior design uses right triangles all the time. And In order to make those designs come to life, construction and architect workers use right triangles all the time. Right triangles, they're everywhere. So, since we can't escape right triangles, we can't avoid them, they're all around us. Let's learn how to use them to help us solve math problems like this. Suppose you're making a sail in the shape of a right triangle for a sailboat. The length of the longest side is 65. You can read the rest. What we're trying to do here is figure out how do we solve this word problem. But word problems are too hard to do in your head. Whenever you have a word problem like this, here's what you have to do. Sketch it out. Take all those words and turn it into a picture. You know what a sailboat looks like, and you know what a sail on a sailboat looks like, so draw a little sailboat. It doesn't have to be a work of art. You just have to get it so that you know, oh, hey, a sail is shaped like a right triangle. And I know stuff about right triangles, so I know how to solve this problem. All I have to do is look at the numbers here, figure out where to put them on my diagram, and then I'll be good to go. Well, it says it's 63 feet high, so you're going to label the height as 63. It says the sail is 65 feet on the longest side of that triangle. We know that the longest side of a triangle is always the hypotenuse, so that's where the 65 goes. And it's asking what is the length of the third side. That's what we don't know, so we'll put an x, and now we just need to turn this into an a squared, b squared, c squared Pythagorean theorem equation. So, which two are the legs and which one is the hypotenuse? Well, x and 63 are the legs, so x squared plus 63 squared equals the hypotenuse squared, which is 65 squared. I'm not even going to finish this problem, because from here, you can just do the math and use a calculator to figure out what that x is going to come out to. But the point is, when you have a Pythagorean theorem word problem, you've got to just sketch it out. Turn it into a picture, turn it into a diagram, turn it into a right triangle. So here's some practice that I want you to try. Practice problem number 1. Kind of like leaving school. Now you're leaving your house, and instead of east, you're going west. And instead of north, you're going south. But can you turn that into a picture? I think you can. Try it and see what you come up with. Oh no, this one has so many words. What are we going to do? You're locked out of your house. The only open window is on the second floor. Okay, I could picture a house and a window being up high. And the window is 25 feet above the ground. Okay, I think I could know how to label that. You need to borrow a ladder from one of your neighbors, but there's a bush along the edge of the house, so you'll need to place the ladder 10 feet. Where am I going to put 10 feet? Okay, the base. You'll need to put the ladder 10 feet from the house. And what length of... Okay, so x is the length of the ladder. I think you could probably turn this into a picture that looks like a right triangle and then figure out how to solve the problem. Try that. See what you come up with, and we'll take a look mañana. All right, remember, right triangles are everywhere, and when you have to solve a problem, sketch it out.